not right. You guys with me? If I take a sample, is its standard deviation going to be the same as the population standard deviation? I would put money, a lot of money, on it not being true. Because the odds of me winning some money are good. That's one kind of betting game I'll play. Right? So I know that if I thought I knew this and I made this formula based on that, and I go, oh shit, I don't know that. I only know this. I only know the sample standard deviation, not the real standard deviation. My interval's got to get freaking bigger to cover my ass for not knowing something. Right? I mean, that is essentially the story. I haven't shown you a lot of the mathematical details of it. It's the same formula. This is still X bar. This is section 7.4, by the way. So here's 7.3. X bar, give or take. But instead of a z-score, now I know I'm going to get some moans, but oh well. It's just another freaking chart. It's really easy to find. Instead of a z-score, I use what's called a t-score. And I want to show you something kind of funny. You're allowed to have these formulas on the formula sheet, right? You just can't have notes. But when do you use a z-score? When you know sigma. When do you use a t-score? When you know S, not sigma. Hey, there's a freaking note in your formulas. That's silly. Why were t-scores invented? To cover our ass for when I don't know the real standard deviation. That's why they were invented. Both of these formulas require what kind of distribution? Normal. So if you don't have a normal distribution, you can't do either one of these things. But if you have a normal distribution and if you have a normal distribution and you know the population standard deviation, bam, that guy. If you don't know the standard deviation of the population, only the sample, bam, that dude. Right? That's the idea. Now let's get into more of the details. Real quick, I don't have a lot of time to talk about it, but the backstory of this, there was a guy who worked at the Guinness Brewery. And sometimes I get a few people stand up a little straighter when they say Guinness Brewery is the guy that worked there. He wanted to do some analysis of some data from their stuff, the brewery. But he couldn't do the report without his boss finding out and knowing that he shouldn't have been doing that. So he actually submitted it under an anonymous name. He called himself Student. So you'll see something called the Student's T distribution. Because when he turned it in, when he wrote the article, he turned it in as if his name was Student. Because he couldn't let his boss find out that he was doing this analysis on this stuff in the factory. Kind of an interesting story, right? So that's why that's called a Student's T distribution. But just remember, why was it invented? To cover our butts for when we don't know the population standard deviation. Now, at this point, I think if you're not comfortable looking up z-scores and looking up areas, that's a big problem. You should be, right? So it's not that big of a deal now. It's just going to be another chart. It's not really a big deal. It's just another chart that you turn to look at. Instead of the z chart, you look at the t chart. Still the same formula, basically, right? One little thing about the chart. Now, put it up here probably. I can't remember if I talked about this before. I might have a little bit. Degrees of freedom. It sounds like I'm going to get into a historical lecture now, but what is degrees of freedom? In the book, it's DF, degrees of freedom. Tell me this. If I had 5 numbers, let's say 4 numbers, and I wanted them to average to be 10. How many numbers could I just totally make up? How many numbers do I have total freedom over until I have to stop and go, oh shit, I got to make it a certain thing so that it comes out to the right average. So if I want this to average to be 10, I can make the first number whatever the hell I want to, right? I really want you guys to get, if 4 numbers average to be 10, can anybody tell me what they add up to be? If 4 numbers average to be 10, what must they add up to be? 40, because 40 divided by 4 is 10. You guys get me? The average is the sum divided by the number. So what do I divide by 4 to get 10? 40. So they have to add up to be 40. So if I make the first one 1, and I make the second one 30, and I make the third one, I could even do more than what I'm about to do, but I won't. And I make the third one 7, do I have freedom still over the last number? Can I make it whatever the hell I want it to be? No, it's got to be what? 2. Because now these all add up to be 40. Do you see? So what's the degrees of freedom? If my sample size is 4, my degrees of freedom is 1 less. My degrees of freedom is n minus 1. It would be 3 here. So degrees of freedom is n minus 1. Some of you guys have totally tuned out. I can kind of watch as people tune out, like a little lights go off. Boom. All that crap, though, I just want to explain to you why it is n minus 1. But here it is. Let's look at the chart. Let me put it up on the screen, too, so you guys can see it. It's actually in the very back. If you go to the very back of the book, or the insert. If you go to the very back of the book and turn one page in, there it is. Right? You want to do that? Whoa. Okay.
On the new formula, the C formula, is that S or standard?
S. Yes. Standard deviation of a sample. Right? Standard deviation of a sample. Yeah. Rawr. So how do you read this chart? That's always a good question. So for example, if I had a sample of 41 and my S is 2.89, would I use a Z or a T?
T.
Why? Okay, that's one thing. What's the second thing? What has to be true in order to use Z or T? It's going to be normal. Why do I know this is normally distributed?
It's greater than 30.
And let me say a real quick thing. There's always so much. In the homework, there's a really good problem that nobody got right yet. If I take a sample of 38 things, will that sample be normal? No. I don't know. I have to graph it. Maybe it looks like this. The idea is if I take a sample of bigger than 30 from a population, all samples would then make a normal distribution. If I took all possible samples greater than 30 from a population, the result would be normal. Not each sample. Each sample could look like whatever the hell they want to look like. So be real careful. When I take a sample of 41, the population of all sample means would be normally distributed. So I know it's big enough to be normal. Normal, check. And I only know S. So you're right, you got to use a t-square. What would your degrees of freedom be?
41.
Good. 41 minus 1? 40. And let's say I want to be, one last thing I got to tell you. Let's say that I want to be 95% coffee. So see how this works. If I'm 95% confident, how much area is in both tails outside? If there's 95% in here, there's
0.025.
total area outside would be 5%, right? 0.05. So the area in two tails is 0.05. Now notice if you said the area in one tail, how much is the area in one tail for 95%?
0.05.
You'd still be in the same column, wouldn't you? That's kind of nice. I don't care if you make it 2 or 1. I don't care. You're still in the same column. Now notice this real quick. If you go all the way down, what's the z-score for 95%? Who remembers? 95%? 1.96. If you go all the way down, the z-scores are at the bottom. Because if you get a large sample, how much do you have to cover your ass? Not much. In fact, if it's large, you can just use the z-score. The smaller your sample gets, look at the t-score. Don't they get bigger and bigger and bigger to cover your ass more and more and more because it's less likely that the sample standard deviation is anywhere near the population standard deviation. So the smaller your sample gets, the more you got to cover your ass. Where should we stop? Like we said, 40. Right there it is. There's my t-score, 2.021. Can you guys see that? So the work is the same. Instead of looking here, or maybe here, I just look here. And then I still plug it in the same damn formula. It works just like a z-score does. It works like a z-score. So what about this situation? What if I have n equals 11, population appears normal. S is 1.92, and I want to be 98% confident. What do you guys think? Can I use a Z or a T?
T.
T. Why? 2 reasons. I only have S. That's one thing.
You said it's normal. Here's normal.
It's normal because I said it was. Is the sample big enough? No, I don't care because it's freaking normal to begin with. Right? Yes, ma'am.
So if the number's not big enough, you'll tell us.
I have to. If that wasn't there, you would say, I can't do shit. Or you'd say, I can't do anything. However you're feeling. You guys see what I'm saying? But if they tell me the population looks normal, the sample does not have to be 30. It could be 1. It's already normal, right? I don't have to somehow make it normal. It's already there. What's my degrees of freedom? So we got S, check, and we got normal, check, so I can use a t-score. Degrees of freedom is 10. 98% confidence, so how much is in 2 tails? 2%, right? There's 98% in here. There must be 2% outside. So I want to go here, and I want to stop at 10. Kabang. And I would just plug that in the formula just like I would have plugged the z-score in. I just use this score instead, the 2.764, right?
Into which formula?
Nope. Right? I really want you guys to see how that's really the same thing. They're the same exact formula, aren't they? They are the same. It's just that that is always going to be a little bigger than that would have been to cover your ass a little more because there's something you don't know that you should know to really be able to do this, right? So that t-score just covers your ass a little more and more and more. If your sample gets smaller, it covers it more and more and more. Yeah.
So I was gonna ask you, just so like on the one that you were just doing, so you had a degree of freedom of 10, trying to figure out how to use the chart, degree of freedom of 10, and then because of the 98, you had 2 in area in 1 tail.
2% and 2 tails.
Okay.
And don't make too big of a deal. If it's a 98% confidence level, how much is outside? 2%. Or if you want to go one side, how much is on one side? 1%. Both of them are here. 1% in 1 tail, or 2% in 2 tails. And here's the picture for that. If I have a 98% confidence level, there must be 2% total outside, right? So that's 2% in 2 tails, which is the same situation as 1% in 1 tail.